Well, folks, you know what time it is, and fabulous. Here we are, EOC Countdown Bell Work number 24. And guys, couldn't be better timing because why? We just learned this on yesterday, how to graph a quadratic, okay, in our 3 easy steps, right? So I'm going to go over all 3 steps with you. Step 1 is to graph the vertex, right? So how do we do that? We have to find the x first, okay, by using this little formula, right? You're going to, in the vertex, you're going to solve for the x and the y value, okay, of the vertex. So first we have to find the x of the vertex, which is the highest or lowest point of the parabola, right? So once you find the x, then you can solve for the y, okay? So a quick question for you is to take a look at this function and say, oh, well, this a value is positive. So therefore, the parabola is going to be a smiley face, and the vertex is going to be at the bottom of that smiley face, so that would be a minimum, okay? So to find the vertex, we have to use negative b divided by 2a, and so this is our a term, this is our b term, this is our c term. So our b term is 2, all right? So we're going to put 2 in that formula, and our a term is 1, so we're going to put 1 here. So the opposite of a positive 2 is negative 2. 2 times 1 is 2. So simplified, it comes to our x value of our vertex is a negative 1. So go ahead and put negative 1. And now that we know, and you're going to do this again and again and again, okay, 2 more times. Now that we know what our x value is, we can plug it into our function here, okay, to find out what the y is equal to. Because even though this says f of x, we know that it means the same thing as y, and y is equal to whatever the result of this is. So since we know that our x value of our vertex is a negative 1, if I put negative 1 in here for each of our x values, right, and do the math, then you're going to find out what y is equal to, because once again, y is equal to whatever the result of this is. So if you do the math with me, okay, negative 1 squared is 1, 2 times negative 1 is a negative 2, and negative 3. So 1 minus 2 is a negative 1, and negative 1 minus 3 is a negative 4. So let's put negative 4, okay? So now we know what the vertex is, so now we graph it. So we have to graph a negative 1, negative 4. So we go negative 1, down 1, 2, 3, 4, and put your dot, okay? So guys, that's your vertex. Okay, that's at the bottom of the parabola, and now we have to pick 2 points, right? Step 2 was pick 2 points. Okay, and what I always recommend is that for the 2 points that you pick, okay, make sure that you always choose the x value. That's not x sub 1, that's a comma. Sorry about that. Okay, so make sure you always choose 0 and positive 1 for your x values for the 2 additional points. Because why? The 0 and the positive 1 are the easiest to plug into our quadratic and do the math to figure out what the y is equal to. So you just basically substitute what x is equal to into the quadratic, do the math, and you find out what y is equal to, okay? So our x value here is 0. So if I substitute in 0 and 0, right? So 0 squared is 0. 2 times 0 is 0. So 0 minus 3 is negative 3. So that's our first point, right? So now you're going to plot 0, negative 3. So we're not going to go anywhere right or left on the x-axis. We're just going to go down to a negative 3 on that y-axis. Okay? And finally, positive 1. So now you just do the same process. Substitute 1, your x value, right, into the quadratic again. And we have 1 squared is 1. Okay? plus 2 times 1 is 2 minus 3. So y is equal to 1 plus 2 is 3. 3 minus 3 is 0. So 0. Okay, now let's graph our second point, 1, 0. So 1, 0, right there. Okay, so step 3 is using the axis of symmetry. Okay, guys? So the axis of symmetry goes through the vertex, you guys. Right? And what did we say yesterday was the equation of this axis of symmetry? Well, it crosses over our x-axis, and it crosses over our x-axis at a -1. So the equation of the axis of symmetry is x equals 1. Excuse me, -1. Okay, that's just a sidebar. Moving on. So we're now going to use this axis of symmetry to mirror image the points that we've already graphed here. So from the axis of symmetry, we went 1 space to the right for this point. So from the axis of symmetry, we go 1 space to the left. And then from this axis of symmetry, you can see that there were 2 spaces to the right here. Okay, so from the axis of symmetry, you have to go 2 spaces to the left. And then we connect our dots. Okay, so based on this, we know, let's look at question A. It says, what are the zeros of this function and where are they located? Okay, this is something that we have to discuss. So everyone write zeros and roots. Everyone write that down. And then also write solutions. Okay, guys. Solutions, zeros, and roots all mean the same thing. And you have to be comfortable with those 3 terms meaning the same thing. So on the algebra EOC, they could either ask you, what are the solutions of this parabola? What are the zeros of this parabola? And what are the roots of this parabola? Okay, meaning they all mean the same thing. How many solutions does this parabola have? Well, it crosses over the y-axis at 2 points, so there are 2 solutions, okay? And then they're located, it says, and where are they located? They are located on the x-axis. Okay, and then it says determine whether the function has a maximum or minimum and identify it. Well, obviously, since this vertex is at the very bottom of the parabola, the exact point where the parabola changes direction, this is a minimum. Okay, and the vertex is at a -1, -4. -1, -4. I'm just going to throw this into the bell work as well. What you can also notice is that not only do we have a positive smiley face parabola here because our A value is a +1, okay? We can also identify the domain and range, okay? So the domain, as we discussed yesterday, being that these arrows, this is a huge clue here, guys. The arrows mean that this parabola goes on to forever and ever and ever into infinity in both directions, okay? So the domain of this parabola would be all real numbers. Okay, I'm just putting this in here, even though that's not part of the question. I think it's a good review. And then the range refers to our y values. And what we said yesterday was you have to identify where does the parabola begin. Well, on right here, it begins at a -4, and it goes up in the positive direction. Right? So it would say our range would be y is greater than or equal to -4. And that is our EOC bell work number 24.